Okay, so for the next, oh goodness, for the next example, we're going to solve it the same way, where we just use inverse operations to get back towards the z. So the first thing I want to do, I have 9z squared equal get z squared by itself. And what we end up with is z squared, because these 9's divide to 1, z squared is equal to 16 over 9, which is not a reducible fraction, but you'll notice that both the top and bottom are perfect squares, and that's actually going to help us in this case. So again, we're going to take the square root of both sides. It's the square root of the entire fraction now. It's not just the square root of 16. And then that, of course, becomes z, and 16 over 9, the square of 9, which is, of course, equal to 4 thirds. But, of course, since we took the square root again, there's both a positive and a negative square root. So I'll show you a symbol that we use to show the positive and negative when it's the same absolute value. So when the value of this is the same for both roots, we can just also write plus and minus, plus and minus 4 thirds. And that's really it when you're taking the square root. The only one you might want to be careful on when you look is, I think, well, there may be others, but 9, I think you'll see an interesting sort of thing that you want to pay close attention to, and don't make any sort of crazy mistakes. Alright, so you can do those practice problems. Again, the solutions should be on Blackboard, and you can go ahead and check them and move on to the third part.